Tonight is October the 20th, 2019. This is an amplifier I've been planning on building for quite a long time. Finally got around to it. A lot of it has been because of the comments and the suggestions. All the thoughts that you guys and gals have given me out there, I certainly appreciate it. You have no idea how much I appreciate it. And here it is. These are 1625s, which is 12 volt 811. Excuse me, not 811, a 12 volt 807. These are probably World War II vintage or something very shortly after that. They're actually a 6L6. They have the plate dissipation rating of a 6L6 GC, which is 30 watts. But they you can run them at a lot higher voltage because it's got plate caps. Now this thing is powered up right now. I'm using a UTC S40 transformer. The interesting thing about it is the beautiful UTC logo is upside down. Look at that. I guess they were thinking it'd be mounted the other way around. I have a number of these UTC type transformers, and in a 20 meter 3-400Z amplifier power supply. I do actually have a larger one of these, much larger. This is not the 40. This is a, darn, I don't remember what it is. I can't see there where they get my head anyway. Anyhow, it doesn't really matter. This is that magnificent Triad output transformer that says it's rated at 65 watts from 7 hertz to 50 kilohertz. Okay, so whatever. Let's get down to business. This little Poseidon board is kind of interesting. They don't make them anymore. And up until just a few days ago, I just, because of laziness, I just Google the schematic, but it's not available anymore. I'll show you what it is. It's this schematic right here from a DIY driver. Shows up like this. Let me see if I can do this without too much. And that's what it's called right there. DIY tube instructions for assembling and operation. Well, they say it's $10 for this, so maybe you could buy it. I don't know. But anyway, it used to be free. But it's not even there anymore. But anyway, I have a bunch of copies. Let's see if I have a copy that hasn't been scribbled all over. Here is a copy of it. If you actually have to have it, I think I've got the whole thing in there. I'll hold it there long enough that if you really need to look at it, you could pause the video and hopefully the picture will be clear enough you can see it. Got a 12AX7 driving a 12AU7. I even have the LM334 in there. The only thing I had to change in this is this 1 meg resistor right here. I had to change it to a 0.5 meg because I didn't have enough range in here to balance the bias voltage, to balance the cathode currents. But everything else is exactly to specs. I built it exactly the way that they recommend. So there you go. I used a 12AX7 and a 12BH7 instead of a 12AU7. It seems to be a little bit better. Okay, I'm going to turn it over in just a minute, show you underneath it, but let's make a quick measurement. The way that I adjust the balance on the cathode currents is I put my meter between here, and I adjust for 0, and I adjust that little pot right there for a 0. So that makes my tubes balance, and then, I don't know if you can see it without, right there in the back. I'm trying to see it here in the camera without moving it. Yeah, you can see it right there. That's the main bias level right here. As I turn it up, the way that I've got it put in there now, the bias level becomes more negative and the cathode current decreases. I thought, well, maybe I should have done it the other way around, but I guess it doesn't really matter. Oh yeah, let me show you the back of it. The back of it turned out real nice. Let's see if that's still in the camera proper. Yeah. So I mounted this one piece right here that's got the plug, it's got a fuse right there, and it's got the on-off switch right there. I almost made a mistake by putting it in the middle of the chassis because that's some really important real estate right there, you might say. But if I put it over here, it covered the pin connections to this transformer, which actually probably would have been okay. This is common 4, 8, and 16. The wires on this transformer are actually still quite nicely color coded. You can actually read them. So I'm certain this is 4, 8, and 16. And you might. This amplifier right here is really just a beautiful example of how you can change the secondary impedance by what the load impedance is. Hope I can find this without too much fumbling. If you notice, this is an 8 ohm load right here, and I've got it on common and 4. I got it on 4 ohms. Well, if you put 8 on 4, then that means this is a 4K transformer for 4, 8, and 16. 4K. Well, 4K is really low. Let me see if I can find this. Hopefully quickly. 807. That's what you have to look up nowadays. Every time you look up a 1625, they just instantly refer you to an 807. And it's the same thing. And there's the beautiful 807. Well, anyway, 4K, if I put 8 ohms on the 4 ohm winding, then the secondary impedance that's reflected, or the primary, which is the high Z side, is going to be 8K. And here's what we're running it at. I think this stuff actually comes out pretty good in the video. I'm running it at 600 volts. I'm running it as a Triad, UL, ultralinear, so this is not true. This is run as a beam power tube. About minus 32 volts or so on the grid, and so on. 200 milliamps of plate current. 48 milliamps. That's a really important number right there that needs to be discussed. If it's, say it's 50 milliamps, 600 times 50 milliamps is 30 watts. So it's running right at the absolute maximum plate dissipation. And it says we can get about 80 watts out of it. That is in this beam power tube mode, not triode mode. Now I know that some of you are going to tell me that UL is not triode, but for all basic purposes it really is, because you're running the screen at the same potential as the plate. It's just another form of triode mode. But because of those UL taps, we have some negative feedback up there, which enhances it, and it's a good thing. But you have to build a separate power supply. You have to build a screen supply to run it at 300 volts. So I've got a plate supply and I've got a bias supply, but I don't have a screen supply, again because it's UL. So there you go. Okay, I think that's enough of that book. So if we turn it around, and let's quickly just look at some power output, because I got to take you to the basement and show you what I'm doing down there. It is out of sight. It's been quite a project for the day. Okay. Well, actually, I think I can do this real time. Well, no, yeah, maybe. Okay, let's hook up our oscillator. Let's turn this guy down. Hook up our oscillator. We'll set it to 1 kilohertz. Okay, I got to set up and I'll be right back. Be back in like seconds, you know. Okay, I've got it set up for 1 kilohertz. I'm not going to go through all of the measurement process tonight. That's just too lengthy, because I got other things to show you, and I like to keep my videos nowadays 15 minutes or less. But here's what it's doing right now. We're driving it with 1 kilohertz, and there it is right there. I think you can see actually all that pretty clear. 60 watts, 1 kilohertz. There's its THD, 0.6%. It works. It's doing a beautiful job. This is its voltage. You can see the two numbers are the same. This is its voltage across 8 ohms. I'm measuring it at 8 ohms because that's the load. And so it does 60 watts quite nicely. If I run it up just a little bit more, it starts to clip. So it's right below clipping level at 60 watts. Well, actually I like to run it up to about 1%. Yeah, clipping actually makes the distortion go plumb out of sight right quick. There you go, 0.998, 62.9, 62.9, well 63 watts. Right here is where it starts to clip, and it sounds so good it gives me chill bumps to listen to this thing. It is powerful. But down at 50 watts, the distortion you can see is 0.5%, 0.5%. There's what it looks like on the oscilloscope. Let me turn around here and show you this oscilloscope of it. This is a really nice high-end scope. Let's take a real close peek at it. There you go. Did that look good? Beautiful. So that's it for right now on this amplifier. Well, no, I got to show you under it. I do have to show you under it. It would be I'd be completely amiss if I didn't go there. And then we'll go to the basement for a quick look at what I'm doing down there. And some of the stuff I've been doing there is pretty laughable. I'm gonna be back in just a second because I'm going to turn it over and power it off and turn it over. Okay, here's underneath it. I'm going to have to hold the camera here. I know it makes some of you guys dizzy sometimes, but I just can't have a fixed camera to show you all the things I want to show you. This is the main power supply right there. Those are 100 microfarad, 450 volt capacitors in series, so I got 900 volts. I'm running 600 volts on it. Using a, what is this, a 5 Henry? Yeah, 5 Henry 200 milliamp choke. Got the equalizing resistors, it's turned off. I've got the equalizing resistors on the capacitors. Here's that little on-off switch, connector, and fuse holder all in one. This is the bias supply adjustment. This is the first resistor to drop it. These capacitors over here are in the power supply. They're actually here and here. And they are the correct voltages, just like they say. They want 430. So I adjusted that first resistor I showed you there, so I got 430 there and 330 there. This resistor right here. You have to do a little tinkering. You have to do that. This is the bias supply over here. And there's that beautiful UTC transformer hookup. Here's the board up there with coming in. Got a gain control. There are a couple of unused pins on the 1625 sockets, so I used them for connections, so I didn't have to add another terminal strip. This resistor right here is a grid stopper. This is actually the grid connection. That's an empty pin. This is the 1 ohm resistor, 1 ohm precision resistors right there and right there across the cathode to ground, so that I can measure that they go to those test points on the top that I just showed you. And here's the plate and screen hookups right here. So that's it from the bottom. There's the 4, 8, 16 ohm down there. There's the white wire going back as feedback. What I did in this one is I made all of the high voltage wires red, or any kind of high voltage on it, whether it be AC or DC. The black wires are the lower voltage. The black wires are AC input or ground, filament, things like that. The white wires are signal level. So here's a signal coming in, going through the Poseidon board and going over and driving the grids of the 1625s. And the green wires are the bias. I think that's all I wanted to show underneath here. Seemed like there was something really important that I thought was kind of interesting, but I don't remember what it is now. So anyway, that is it for the moment. I'm going to, make improvements to it and make another video or two of it. Oh, yeah. Here's something that I'm going to do. Let me show you. Sorry for all the movement of the camera. This is that same board, but it's wired entirely different. As you can see, it doesn't look quite the same if we compare them. I can't compare them without turning that thing over and having to stop the video. But this is wired exactly as a Macintosh MA230 driver, and I've had very, very good luck with that. So I may actually swap this one out for this, because this amplifier puts out a lot of power. It does quite a good job, but it just doesn't meet my expectations as far as 20 hertz or 20 kilohertz goes. I don't know exactly. You guys can give me your thoughts on that. This idea of everything has to be perfect from 20 hertz to 20 kilohertz, I think we're driving ourselves crazy over it. I think this thing gives me chill bumps to listen to. I love it. I absolutely do. Here's another amplifier that I listen to pretty much all the time. It's got the UTC. This is an LS. I don't remember all those LS numbers. Anyway, this is a 5K, running it with the EL34s, 5U4, genuine, straight across, no baloney Williamson design, except for the output transformer. His output transformer had like 100 Henrys, I believe, in the primary. That's pretty hard to get. I'll tell you another thing. 5U4s are just a crazy tube to use as a rectifier nowadays, because if you got a weak one and you start loading it, your amplifier starts performing very poorly. It really does. Let's turn this thing back over. Okay, back to the 5U4 discussion. We use them because there's just a bajillion of them out there, and we love them for some reason. But the little 5AR4s are actually quite a bit better. You do get higher voltage. I don't need higher voltage. I really don't want to raise to higher voltage. And here's a solid state replacement for them. It's called a 1N1239. You can actually Google it. You can search for that number. I say Google all the time. You can actually search for this or go to eBay and you can find a 1N1239. They're not much money. But you got to be careful. You got to be careful just willy-nilly replacing vacuum tube rectifiers with solid state, because well, it's going to be quite a surge current coming in, charging the capacitors and what have you. We don't want to get into all the detail of that. But if you got a weak 5U4, and I do have some weak ones, you know, if you get one of these ancient old things like this, that doesn't mean it just because it's this type, this Coke bottle type, and it's ancient, doesn't mean it's bad. But it sure as heck doesn't mean it's good. And when they're bad, you'll get great performance in this amplifier. I've just experienced this. That's why I'm bringing it up. At 30 or 40 watts, you bring it up to 50 or 60 watts, and it goes kaput. You go, well, what's the problem? Well, your rectifier is soft. That's actually true, very true, of the old Collins S-line equipment that I love and I operate every day. If you've got soft rectifiers, you can crank up your output, it'll run up to 100 watts, and then it'll just slowly, not slowly, but pretty quickly, just drop back down to maybe, you know, 70, 80, 60 watts, whatever. So these old guys are marvelous. But there's a lot of them out there that's pretty weak, and when they go soft, I know that musicians like them. They like that sag in voltage. I can understand that. But you know, are you actually going to be going out looking for weak rectifiers? Well, I wouldn't think so. But anyhow, rectifiers matter. They really do. Here's the my test setup. I did match the tubes. I've got a bunch of 1625s, 2, 4, 6, 8, 10. So I got 14 down there and 2 plugged in. So I got 16 of these things to play with. I think that's about it for this one at the moment. I'll do some more updates to it. I may see if I can how I can improve its frequency. So it isn't bad. It isn't a bad thing. But you know, it isn't flat either from 20 to 20 kilohertz. So but it just sounds beautiful. Let's go into the basement and take a look at that right quick for the update of the AM transmitter. You're gonna like this. Okay, approaching this thing, I'm gonna have to hold the camera for the whole thing. But this is what the AM transmitter is going to be built into. I got this cabinet in today, and the funny part about it is I had to laugh after I really realized by mistake. This cabinet is a cabinet for like servers, you know, computer stuff, but they're fairly inexpensive. Anyway, I ordered a 42U. U is a unit, and a unit is 1.75 inches. So if you multiply 42 times 1.75, you'll see its height. And the height from the floor down here to the ceiling up here gave me, and I'm not exaggerating, that's why I started laughing after I got this thing put together, it gave me about 1 millimeter clearance between here and the ceiling. And the ceiling is not perfectly flat, so you know where that went. Well, anyway, after going through all the assembly, I had to disassemble it and go out and cut the tops off. So I actually cut it down to about the same size as my old Collins cabinet over there. Okay, now there's actually nothing here that's going to be working. I just want to show you where it's going and what my thoughts are on it, and I'm always open to good suggestions. I'm planning on putting the power supply down there, build it up, just top build it, so to speak. I'm going to use those big transformers I got from Sandia Labs. They're just absolutely beautiful. I have to do it. And I guess I'm going to have to use the MV rectifiers here in the front. I mean, when it's all over with, I'm going to put some sides on it, of course, some metal sides so we can see into it. But it's got to be protected. It's got to be safe. You know, 3,000 and 4,000 volts is just not something you can play with and willy-nilly. You gotta make it safe. Okay. Anyway, the power supply components will be down here. That's just there, just to look at for the moment. That's a 17 by 17 inch chassis, and there's the 833 amplifier. It's not necessarily the one I'm going to use, but it could be. It'll be running Class C. I think what I'll do is build a power supply, as I keep saying, down here at the bottom, and this will probably be the modulator and the RF section up here. And I got some extra room for whatever. Let's look at the other side. Let's see if I can get around here gracefully. I love this amplifier. I think it's beautiful. There's the 833, if you like that stuff. I didn't actually want it as long as this piece made it. I actually wanted it, you know, shortened up to about right there. You know, just a few inches past the chassis. But I can't shorten this. I can shorten all these right here. And if I want to shorten the whole chassis, I can't be using these, and I actually like those because this will allow me to mount some big components down here, put all the weight at the bottom. Here's some chassis that I use. I've been asked this several times. Here's who I buy them from, right there. Mouser. It's made by Hammond Manufacturing. That's the part number right there. You may not want this particular one. This is a 17 by 17. They're about $65. These chassis are not free, but you can actually start with that number, and that'll get you in the ballpark if you want to buy different ones. I'm going to have to do a little bit more work here on the slides because they need to be out a little bit more. You know, I mean, this cabinet was not made to slide chassis in. I need some different spacers right there to move these rails out and whatever. But anyway, that is the progress on the AM transmitter. Not exactly sure where I'm going to put it in here, but I'm going to figure it out. Comes with all this hardware right here, but the jillion little pieces that I had to take apart and put together, you know, several times tonight. I don't know why I'm showing you all that. Here's my old equipment I love to show. The old 4CX1000 amp built in that 1947 Collins 30K1 cabinet. And my pretty little KWM2A 51S1 receiver. Of course, you got to have oscilloscopes everywhere. There's not much on 20 meters as you can see right now. This right here is from my Wi-Fi network around here. So 20 meters is very quiet at the moment. And the S-line equipment. I've been playing a lot with microphones lately. This is a pretty little mic, but it's not original. It's not a stock Kenwood MC50. It's actually got a condenser type microphone in it, and I put a battery in the bottom, see, 9-volt battery inside, and I had to put a little gain pot right there so it doesn't overdrive the front end. So I think that's about it for right now. So that's the update on the amplifier. The amplifier is working, it's beautiful, and this is the update on the AM transmitter. I'm going to actually probably make it for 40 meters instead of 20. So thank you for watching. Thank you for all your comments. This is I really enjoy this. I enjoy the work. I enjoy the camaraderie and the sharing of information and what have you. So be safe. Be real careful around that high voltage. It's not your friend. And thanks for watching.